Good morning. Good morning. Thank you very much for joining us today for one more webinar of the NewTechAqua webinar series. Today we are organizing a webinar entitled Innovasea's Broodstock Management Software. But before we start, let me introduce you very briefly about the project NewTechAqua. This is a project funded by the Horizon 2020 Research and Innovation Program under a call that was launched in 2019 about sustainable European aquaculture 4.0 nutrition and breeding. Under that call, 4 projects were funded, and those projects are e-efficiency, intelligent fish feeding through integration of enabling technologies and circular principle, aqua impact, genomic and nutritional innovations for genetically superior farm fish to improve efficiency in European aquaculture, or project NewTechAqua, new technologies, tools and strategies for a sustainable, resilient and innovative European aquaculture, and future EU Aqua, future growth in sustainable, resilient and climate-friendly organic and conventional European aquaculture. NewTechAqua project is an innovation action. The acronym NewTechAqua stands for the title New Technologies, Tools and Strategies for a Sustainable, Resilient and Innovative European Aquaculture. The project has received almost 6 million euros from the European Union. That is the contribution, but the overall budget reached nearly 7 million euros. Project started in January 2020 and is finishing this December at the end of the year. And it is coordinated by the University of Bologna, and we are in the project 25 partners from 9 countries. Those are Belgium, Croatia, Cyprus, France, Greece, Italy, Norway, Spain, and the United Kingdom. So very briefly, in the project, there are partners from research and development institutions, research centers, universities, that's the University of Bologna, the University of Venice, IRTA, HCMR from Greece, University of Bari, NOFIMA, IFEMER, CISAF, University of Las Palmas de Gran Canaria, DFMR, and the CNRS from Italy. And a significant number from the private sector, 12 partners, either coming from fish farming companies, biotechnology companies, aquafeed producers. Among that, one company that is joining us today for the webinars, which is Innovasea. And there are 3 exploitation and dissemination partners: FEAP, Green Innovate, and CIHEAM. CIHEAM is in charge. I am from CIHEAM, Bernardo Basurco. Together with me is Giada Minini from CIHEAM Bari in Italy. We are CIHEAM Zaragoza from Spain. And so what is the main objective of NewTechAqua? Well, it is to expand and diversify aquaculture production of finfish, mollusks, and microalgae by developing and validating technological advanced, resilient, and sustainable application. The project has focused on the 4 most important commercially finfish species: salmon, trout, sea bass, and sea bream, and in 4 economically emerging new species: amberjack, migre, sole, and mullet, as well as in 2 mollusks, oyster and mussels, and 3 microalgae species. Those are the species that the project has focused, but on different disciplines, as the development of new farming technologies, as aquaponics, or the improvement of production techniques through the application of the industry 4.0, precision farming, or the development of aquafeeds, sustainable aquafeeds, circular aquafeeds, on genetics, an improvement of new species through the improvement of reproduction of the main emerging species, or the development of new products. NewTechAqua has also devoted a very important effort in the transfer of knowledge and in training. Under these intensive programs, we have organized 2 advanced courses, 2 training workshops. We are developing e-learning modules, and we have a very important webinar series. We are organizing 10 webinars. And finally, a school campaign addressed to high school students to let them know about the sustainable development that can be improved thanks to the development of knowledge and the new technologies as those that are developed by NewTechAqua. Okay, as I told you, we are organizing a series of webinars during the month of October. We have organized 6 webinars. Today we have the last webinar of this series. But if you have missed some of the previous webinars, you can watch them in the YouTube webpage of NewTechAqua. That is the address. As the webinars are finished, we are uploading the webinar recording, and for any person interested in following that webinar. And on the month of November, in about 2 weeks, we are going to have the final conference of the project about the tools and strategies for sustainable aquaculture. If you are interested and have time in the agenda, you will be welcome to join us. And Dinos, so you can take the floor to introduce this webinar, please.
Good morning to all. My name is Constantinos Mylonas. I'm from the Hellenic Center for Marine Research. We have our headquarters here in Crete, in Greece, but also facilities in Anavissos. I'm the work package leader of work package 4, closing the cycle of new and emerging species. The objective of the work package was to look at issues related to the reproductive physiology and reproductive biology of 3 important emerging species in the Mediterranean. One is the amberjack, Seriola dumerili. The other one is meager, Argyrosomus regius. And the third one was Solea senegalensis. So we had tasks directed to looking at the dysfunctions that are observed when these 3 fish are reared in captivity, or they're produced in captivity and reared to broodstock function. So we developed some methods for controlling reproduction, maturation, and spawning in these 3 fish. And in addition to the biological work that we did for these 3 fish, we wanted to develop a software platform for broodstock management, because at the time that we started this project, there wasn't anything specifically for this task, and it was something that we were missing both for our facilities here, but also for our commercial facilities. So we joined forces with Aquanetix at the time, Innovasea right now. And we developed a broodstock management platform, which will allow you to follow broodstocks, specific broodstocks, from the beginning of setting them up until dismantling them, but also individual fish that are pit tagged individually, in order to know, of course, what fish you have, what species of fish you have, what is the number of broodstock you have, what are specifically all the individual broodstock that you have, males, females, when they say change sex, if you're talking about hermaphroditic fish, when they were used for egg production, how many eggs they produced over the course of each season that they were used. And also for companies that are doing breeding selection, which is almost all large companies right now, to have information about the pedigree of each breeder, and to know which one was crossed with which other individual over the course of the year. The software, of course, you will hear a lot about the software from the people who developed it, has the ability to not only record data on the management of the broodstock and individual fish, but also attach information and pictures, let's say from biopsies, other charts relating to egg production, and in general, to be able to collect and collate all the information relating to individual breeders and broodstocks through their function in a facility. So this is all I had to say. We had two webinars, as Dr. Bernardo Basurco mentioned, one on the reproductive biology work that we did for amberjack, and one for meager, which are available for you to read. And today, the whole presentation relates to the development and the use of this very, very useful platform that is now available to commercial aquaculture hatcheries through Innovasea.
Okay, thank you. Dinos, well, as you say, we are going to have a webinar just focus on this new platform. Diogo Thomaz is going to make 3 presentations, starting with the introduction of the platform, and a second presentation about how to use the platform, and a last one about apply samples of how to apply work with the platform. After each of the presentations, we are going to open the round for questions and answers. And for you, just let me tell you that the application we are using, that is Zoom, has a tool normally it's at the bottom or in the menu, it depends where it's placed, which is the Q&A, questions and answer. This is the one that we prefer you to use. There is also a chat, but we would like you to use the questions and answer. And I think that's all. And then I stop sharing the screen, and Diogo, please, is your turn.
Okay. Can you see my screen?
Not yet.
Oh, sorry. Forgot to press share.
Here, yes. Okay.
All right. Okay, well, thank you very much, Bernardo and Dinos. My name is Diogo Thomaz, and I am running the office of Innovasea for Europe, the Middle East, and Africa, which is based in Greece, just next to Athens in Corinth. As Bernardo explained, and Dinos, I'm going to present to you in 3 parts the Aquanetix, now Farm 360 platform for broodstock management, and we'll make a little opportunity if anyone has any questions in between the parts. It will help break the presentation and make it easier for you to digest. So let me start. I'll do a brief introduction about what Innovasea is. So Innovasea is a US-based company, but with a presence all over the world, with offices in Canada, in the US, and now in Europe, in Norway, in Chile, the UK, and small presence in other parts of the world, but with projects on aquaculture technology all over the world. And the core purpose of Innovasea is enabling the sustainable use of our oceans and freshwater ecosystems. And as you will see briefly in my brief presentation of the company has a wide area of products and services, but they are all focused on this core purpose. Okay, and the core values are innovation, authenticity, collaboration, commitment, and stewardship. And I put it here because innovation is number one there, not by chance. The company has a strong research and development nature, is involved in dozens of research and development projects, both internally funded as well as funded by national and international organizations, mainly in the US and Canada. And now with our presence here, we will be taking part in more and more research projects in Greece and in Europe. The kind of common, let's say, concept that Innovasea's technologies are focused on what we call precision aquaculture, which is a circular approach to constant improvement in our performance in terms of sustainability, in terms of quality of production in aquaculture. So we have technologies that help us monitor the quality of the environment and the behavior of the fish. Then, using this information, this data, we interpret and we develop predictive models that we use to make decisions about what is the best course of action for each stock in production. And then with these decisions, we act, we put these decisions in practice, and we continuously monitor the impact of these actions through observation again, interpretation, decision, and acting again. So this is an endless cycle that has as an ultimate goal to improve productivity and performance of our aquaculture projects. The company acts in all areas of aquaculture, from broodstock and hatchery to nursery, grow out, both land-based and ocean-based grow out, and harvest. And there are 4 key divisions. 3 of them are aquaculture divisions, okay? The open ocean aquaculture, land-based aquaculture intelligence, and fish tracking. Fish tracking is not directly an aquaculture area, but I will just tell you just a bit about each of these. On the open ocean division, there's been a focus on being able to farm the oceans wherever you are, independent of if there are storms and other actions of the environment. And there is a focus on submersible aquaculture with cages that are at 10, 15, 20 meters underwater. And these resist any type of storm and allow you to farm practically anywhere in the oceans. Together with these cages, there is a technology for monitoring, both video monitoring of the fish and the infrastructure, environmental monitoring, and submersible feeding submersible cages. So there is a whole set of technologies around this. The land-based aquaculture division is a provider of complete solutions for RAS aquaculture, from concept to design to implementation and equipment for RAS systems for all areas, from hatcheries from laboratory facilities to hatcheries to grow out. There is a special expertise within the company on the management of dissolved gases and on the development of control systems for RAS, and these together allow you to optimize water conditions for the fish and maximize production. The aquaculture intelligence division is responsible for mainly developing technologies for monitoring the water quality through acoustic sensors. In fact, Innovasea sensors are used in more than 55% of all salmon cages in the planet. So they are robust and effective and long-lasting sensors. Apart from measuring water quality, the company also has the technologies for you to control oxygen levels in cages through aeration, oxygenation directly in the cage. There is a biomass pro camera for you to get a distribution of sizes of fish in your cages or tanks. There is technology for you to monitor plankton blooms, algal blooms, and be prepared to manage their impact on your farm. There are also cameras for fish behavior, for satiation assessment, etc. Finally, the fish tracking division is a leading acoustic telemetry provider. Okay, they are used at all major fish tracking networks globally. There is a lot of, this is more of a research oriented division in the company, provides knowledge and understanding of fish behavior and movements, enables regional and global data sharing among researchers, and supports data-driven resource conservation and management worldwide. You can see the network of deployments is clearly global. Okay. But now let's focus then on the broodstock management software, which is today part of the Farm 360 project that is within the aquaculture intelligence division of Innovasea. Before going into the broodstock side, let's explain what is the farm management software. Until today, as Dinos explained, this was Aquanetix since 2013, and now it's part of Innovasea. And what is developed here is was probably the first cloud-based aquaculture farm management software, which today is not such a novelty, but it was back in 2013-14. It allows for you to fully trace batches of eggs and fish from stocking to harvest. Okay, even from broodstock to harvest. You could split fish, grade fish, mix fish, etc. The software was capable of tracing these fish, was capable of interpreting all the actions that you did to the fish, feeding, water parameters, samplings, etc. And it always allows you to know the status and the performance of each of the stocks of fish today. Okay. The data is in one database, and it belongs to the company. Okay, this is important because in many aquaculture companies, data is in the hands of the farm manager in his or her Excel files. Okay, and as the manager moves away to another job, it takes all the information of the company with him or her, and this leaves the company with a gap. With applications like Farm 360, the data belongs clearly in the company. We were one of the first companies to develop a mobile app for collection of data. It's easy to use, so workers in the farms can collect the data on the spot when things happen. But also it's very easy to collect data through a web dashboard, and also to visualize reports and performance KPIs directly from the web dashboard. We are working with a BI platform that is linked to your data and allows you to do a number of dashboards and reports. It's a very powerful tool for data analytics that you can use and get the most out of your data, get the most intelligence out of your data through this platform. However, you can also export data in Excel format or CSV format or any other type of typical formats that you can use for custom analysis of your data. Now, what was the purpose in this project was to add a broodstock management, let's say, module to the Farm 360. So this would also be cloud, of course, because it's part of the Farm 360. It will allow now traceability, not of groups of fish, but of individually tagged fish. So from the moment you record that you tag a fish in your tank, in your facility, to the moment that fish dies or is culled or is harvested or sold, throughout the life of the fish in the system, you should be able to try to trace individually tagged fish. Okay, if you move it around, whatever water parameters, feeding, whatever samplings you do, you should be able to get all that information linked to this fish. Okay, again, the data is stored in one place and belongs to the organization. Okay. And we have the same mobile app that allows you to easily collect data. Now the mobile app allows you to collect data on the individual fish as well. We have the same BI platform that has, as I said, powerful analysis capabilities, but you can also export data to Excel and to other custom formats for analysis. So having the farm management or the group tracing bit where that traces the fish from stocking, you feed the fish, you transfer to another cage or tank, and you feed it again, transfer until you harvest. Okay, now you have the possibility of tracing the fish from the day that you tag it up to the day you tag the fish, you collect samples, you move the fish around, you sample, move around until it's dead, let's say. Now you have the possibility of having these two together and keeping not only the information linked directly to the individual, but also the information linked to the groups and to the tanks or cages where the fish were whilst in the system, okay? Now, PIT tags, what they are passive integrated transponders. Basically, you have a little chip that is linked, it's powered by a coil. When an electromagnetic field approaches this coil, it generates some power, and the chip emits a code, a unique code that can be a decimal or an hexadecimal code. This is one example, and this allows you effectively to have each fish uniquely tagged with a unique code. Okay, so it's like giving unique names to your fish. You put tags in fish using a syringe. The tags are approximately 1 millimeter thick, and often you put them on the dorsal muscle there, but you can the tag lives there. It can be also placed on other places like the abdominal cavity, etc. You read the tags with the tag reader. This is that little reader that sends an electromagnetic field and receives the tag code. Okay, and in this display you will read the code of the tag, so you know that this fish is XYZ. Okay. Why should we track individual fish? Okay, because sometimes you want to associate information and characteristics to individual fish and not to the group of fish. Okay, typically in fish farming or shrimp farming, you will sample the pond or the tank and you'll get a mean weight, and that's a characteristic of the population there. Sometimes, for some reasons, you may want to actually track individual fish and know the weight of that fish, or the length, or the genotype, or that it was treated with this particular treatment. Okay, and these are characteristics that you want to associate with individuals, and you can only do this if you can actually pick out the individual from the population. And PIT tags or tagging works in that direction. Okay. You may want to measure individual performance. So if you're a group of fish, for example, in the tank, and you are doing a selection, and you want to know who is the fastest grower, then you need to actually have the individuals tagged and be sampling individual fish and know how each individual is performing, so you can do the selection. And very important, if you are working in a fish hatchery or a shrimp hatchery, and you want to set up breeding groups, okay, you need to know which fish to move to the breeding tank, and you can use characteristics that are linked to that fish, such as breeding values and sex ratio. You want to make sure that you have the right sex ratio, you have the right breeding value, and that you are avoiding, for example, a high level of inbreeding in your breeding group. So this is another example where you need to have tagged fish so that you set up informed breeding groups. Okay. What types of data could you be wanting to track? Okay, phenotype information, stuff you can measure, like the weight, the length, the shape. I have a couple of fillets of sea bass there. You can only get fillet yield from dead fish, but you may be doing a selection using a family selection program, and you may have some brothers and sisters filleted in order to give a value to the family. So this is the type of information that you could be wanting to record as well. Reproductive data like the sex, male, female, undecided. In hermaphrodite species, you maybe have a sequence of males then females, or females then males, etc. So you may want to track the sex of the fish, maturation stage, or fertility per fish, etc. In genetics data, you may want to associate genotype data for microsatellites. You may want to associate some genomics data like SNPs to fish. And so you need a software that can do that. So overall, the functionality that was required from this project for the software was that we should be able to tag fish and trace the tags in the system from the time that you tag to the time that you get rid of the fish or the fish dies. You should also be able to sample the fish and record, associate sampling information to each tagged fish. Okay. Here because of the nature of research institutions and the nature of genetic selection programs and of other type of activities research may be doing with fish, what we decided also as well here was to develop to give users the flexibility to define their own sampling types. Okay. And so we don't force specific sampling types. We allow users to define their sampling types and then to record samplings for their sampling types. And here, as you will see further down, we allowed quite a lot of flexibility in this process. So you can have complex variables made up of many values and different types of variables. Okay, even descriptive variables. The software should also allow you to not only track the information regarding the individuals, but also the groups, the groups of individuals. So, for example, feeding or water parameters that are done in the tank, they're measured in the tank. They must be able to be associated to the individuals that were on that tank on the time the events happen. Okay, and data must be able to be exported for analysis and reported within the system. So this was our, let's say, our mandate. Okay, and we make a pause here if there is any questions at this stage before I move to the next phase on examples of what turned out in terms of what software is like today.
Hello, well, thank you, Diogo. I don't see now still questions, so I don't know if participants, we can encourage them to be active and then start making questions.
Okay.
So to be more dynamic.
But if nothing now, I will continue then. Okay.
Okay. So we continue. So probably when they understand how this works, we'll start to.
Yes, maybe it becomes more relevant. Okay.
Okay.
Okay. So I will continue then. Okay. And what we did now, what I will show you now, I'll show you a few videos of the software. I prefer to have recorded the videos rather than do live demonstrations. Okay, so I'll start with a video about tagging fish, how you tag fish or in the software, and how you trace the tagged fish through the system. Okay. I don't know if you can see my video, my screen.
Yes. No, we see that you have to log. Okay.
Okay. So you log into this is now within the RealFish Pro platform. Okay. You log in using your email and a password. Okay. And you are taken to your, let's say, your company's page or the organization's page. Okay. In this case, there is only one site with Broodstock. And now I'm going to start by, let's say that we got one amberjack fish from one location, okay? And we are going to bring it into our facilities. So we give here the information about this batch. Let's say it's going to be a batch of one, just for demonstration purposes, okay? You give it a batch code. You have the possibility of giving an internal code. Internal codes can be used either for grouping in reports or, for example, for linking this batch to your supplier of the fish. Let's say that we brought this fish on the 15th of October into our facilities. Only one fish, one amberjack, weighing 5.18 kilos. And we are going to, on the same date, to stock the fish or put the fish in one tank, in tank M1, okay? So this is how you bring in fish from outside into your facility. And here you'll be able to see when we go into the list of fish, of tanks in our facility, you'll be able to see that the stock that we brought, the amberjack that we brought, is in tank M1. Okay, so the system put it in tank M1. Now let's tag the fish. So on the day it arrived, okay, we tag the fish, and because it was only one fish, we upload the data manually. We don't need to, we could do it with Excel. Often when you tag, you get other information. You get a fin clip, you get the length, the sex, if possible, and the weight of the fish. And then it shows you how to input this data manually. So you just type in the tag code for your pit tag, all right? The origin, you type in an origin for the fish. It's just a way of grouping the fish. The fin clip, the length, the sex. In this case, it is a male. And the weight, when you weigh the fish more carefully in your facility, it's slightly different from what it was, from what you thought it was. It's like 5.75 kilos. We got a little error there on the fin clip. The variable that was created by us was actually requiring an integer there, a number 1 there. So I'll just put a 1 there. And I click OK to record the fish. So the fish is now tagged in the system. What we're going to do now, just to demonstrate the traceability aspect of things, on the 18th, so 3 days later, I'm going to transfer the fish from one tank to another. Okay, so I say that the system knows that the fish is in tank M1, okay, and we're going to move it to M2. We're going to move, in this case, there is only one fish, but if there were many fish, we could decide which fish we are moving, okay? So, but in this case, for simplicity, in this example, we are moving only one fish because that's all there is in the tank, okay? And let's transfer the fish again on a later date. So on the 23rd of October, we move the fish again as a simple transfer from the M2. Notice that the system knows now that the fish is in M2, okay? And we're moving it to tank R5, and we are moving this fish because there's only one. And then let's do a sampling of this fish, okay? Let's say that we weigh the fish again a few days later, so that on the 25th, we choose the system knows now that the fish is in R5, okay? Because it's only one fish, we're going to add the data manually, and we're going to get the weight of the fish. Again, you could sample all the fish or part of the fish in the tank. In this case, there's only one. We are going to sample that fish, and the fish is 6.1 kilos now. We're going to also do a chance to take a picture of the fish, okay? And we're going to add this image to this sampling. So now we have an image. It could have been anything else, could have been an Excel file, a PDF, could have been anything, but it's now part of this, is linked to this individual fish, okay? After this, we are going to sample to transfer the fish yet again on the 26th, from now R5 to, so there's only one fish in R5, and we're going to transfer that fish, and we'll move it to M5, okay? So this was just to show you that we tagged the fish, and then we moved the fish around. We made a sampling, okay? When we tagged, we record some sampling, then we move the fish around. Let's now look at the traceability report for this fish. So if we go to M5, where our fish is, you can see the batch that was stocked, and here you see the full history of movement of this fish, okay, from stocking, from M1, M2, R5, and M5, okay? So the system knows when and where the fish were from the day that it was tagged, okay? You can easily create an interactive map of your facility, okay? This was an image that was sent us by HMRC, okay? And we made it interactive. It's very easy to map this image. And you, by clicking on the actual tank on the image, you have information about the fish. There it is, one male of amberjack. And we can look at the tagged fish and clicking on the samplings. You see a list of all the samplings that we did. Notice the second weight sample on the top there, and the movements of the fish from tagging until today. Okay. And because in this facility there are thousands of fish, we can very easily and quickly select the by species, by sex, by origin, by tank, by weight. You can use these filters and zoom in on your fish. And here we are, the greater amberjack. And here, not only you could see the history of samplings and movements, but you can also see the files that have been associated with this fish. In this case, the photograph that we uploaded. Okay. Think that you can add any type of data here. Okay. And that's the first video here. Now, I'm going to show you how to set up a custom sampling type, okay? Again, we are proud of this development because it has a lot of versatility for different applications of the software, okay? So basically, you go to the settings on the page, and here, this is an area where you can set a lot of parameters in your application, one of them being the fish sampling types, okay? You have some sampling types here already defined by the user, and you can add a new sampling type. In this case, let's add a fat level as a percent, and this is a type sampling type that has one value. We could have a complex sampling type. This one has one value, and we can choose what type of value it is between an integer, decimal, Boolean, or a string. In this case, it's an integer, and we call it percent fat. Okay, this is just for example. Then we can go, and now that we created this sampling type, let's sample fish. Okay, let's sample our fish and record the fat level on this fish. So I go back to our facility. Okay, go to the samplings page, add an individual sampling. So let's say that on the 28th, we sample the fish, which is in M05. And because it's only one fish, again, we are uploading this data manually. We could have it in an Excel format and upload it from Excel. Okay, so you notice that the fat level percent is now in the list of sampling types, and we just put the value. If we wanted, we could associate another file, for example, on the technique that we use to measure the sampling, the fat level. Okay, and now this becomes part of the record of this fish. Okay, so again, if you go to tank M5 and click on the fish and click the samplings, now you see the fat level percent is 21. So all the information that you are recording remains associated to the fish. Okay. Let me go to the next video. I don't think there's nothing else here. Okay, specifically in HCMR's facility, every day, especially during spawning season, every day they are collecting eggs from different broodstock groups. Okay, and this is how they do it. Okay. So how do you record egg collections? So you go to your tank, and there is a little icon with eggs there. You just record that. It pre-fills that it is this species, this supplier, this broodstock group. You give it a batch code. It's up to you to decide on what's the batch code. Again, you can give an internal code and a lot number to the eggs. Okay, to the batch of eggs. In this case, it was a sea bream. It's a communal spawner. You don't know exactly who is the father and the mother, so you don't put that information in at this stage. You can record the number of eggs collected and the number of eggs that were fertilized. It gets the fertilization rate there. You can microscopically check what egg development stage they were, and say 90% was on J or on I, 10% was on I. And in this case, we're dumping the eggs, we're not stocking the eggs. Okay, so this is an example of recording the eggs. You see a little graph there that now shows the eggs collected today. This graph shows the last 30 days of eggs spawned by this tank. Okay. And And now you can also, in some species, for example, in salmon or in halibut, or in some trials, you may want to use a specific male and a specific female, and you squeeze them, get the milk and eggs, and you mix those. So here we go to the tank where the fish that we want to cross are, okay, and so the software already brings up the tank. You can add a distinction thing there on the batch code. Again, you can add an internal code if you want to, a lot number, etc. But the important thing here then is that you're going to choose the maternal tagged fish that you use. So you actually choose the tag of the fish that was the mother or the source of the eggs, okay? And the paternal tag fish. So again, here you choose where the milk came from, okay? So in this case, you're registering a group of eggs that come from one mother and one father, okay? You recorded the number of eggs and the eggs that were fertilized, etc., in a similar way as you did for the other eggs, okay? Again, you are not going to stock these, you're going to dump the eggs, you could sell them, you could also stock if you had an incubation or a larval rearing area, you could stock them directly there, okay? Again, you measure the egg developmental stage and you have your record, okay? So it is possible to collect eggs from a group of fish and record them, or collect eggs from a specific crossing of a male and a female and record that. And the software, if you go here to the batches area, you will see your meager eggs. They are there, and there's the father and the mother are recorded there, okay? Let's continue the videos. A quick video just showing, this is a simple but useful addition. When you have in your facility many tanks, it is useful to be able to filter the tanks by species and by weight. This is also useful in production. But here, okay, let's say that we get the meager that are above 10 kilos, and here it is your tank S1, actually where we got the eggs earlier. Now, so you have an idea that I told you a number of times that we have a mobile app for data recording, and here is how data is recorded. It's important to notice here that each user logs in with a PIN code. This is very important for auditability of your data, because individuals, you know who recorded what when, okay? The mobile app keeps a timestamp, knows the person that recorded the data, what data is being recorded, and gets a timestamp of that as well. So for auditability, even of research projects, we think this has a lot of value. So here we are recording eggs collected from one tank in the same way as we were doing it on the web dashboard. You get to add a batch code, internal code, etc. You type in the number of eggs collected. Notice that it's very easy to use. The keys are big in the mobile phone, so they are easy to use in the lab. And again, you can also record the egg development stage directly on the mobile app, okay? So all the information you are recording on the web dashboard, you can record it here with the mobile app. Again, you can stock them or sell the eggs, okay? You have a summary of your data, and then you send that to the server, okay? If you are on an Wi-Fi or a data network, the data goes into the server within just a few minutes. And just recording here a transfer. Notice that there is a little tag label here, means that there are tagged fish in this tank. And basically we are moving fish. And when you are moving fish from a tank with tagged fish, you see the list of the tags of the fish that are in that tank, and you decide which ones you move. And now you're going to move this fish to G3. You can give a label to the transfer. And here is a summary. You are moving 3 fish from G2 to G3. Okay. So finally, I just want to, we're just pushing the data to the server here. You can also just showing you how to record the sampling. So let's say you're going to one of the tanks here that has tagged fish. You see on the left, you see the tags, and you can just input the weight, the length, and the sex of the fish. With the mobile app, you can only record the weight, length, and sex of fish when you sample fish. Okay, these are the most common samplings that you do. So you can do them with the mobile app. So you are on your tank. Someone is reading the tag of the fish, getting the weight, the length, the sex, and someone is with the mobile app just recording that on the spot. Okay, making it very easy for you to record data from samplings directly on your mobile phone. Okay, and then sending this data to the server, and you don't need to input anything else later. Okay, and you know who was the person that was doing this job. Okay. Now, to finalize here, I just want to show you a little bit about the reporting platform that we have. Okay, so as I said, we work with a third-party BI tool, a business intelligence tool. It's linked directly to your data. Okay, so and it's linked to your data in real time. So whatever you record becomes immediately available for reporting. Okay. And basically, what you see here is a number of dashboards. They are all custom designed dashboards. You can either do them yourselves if you have the competence in-house, or we can do it for you, okay? But basically, you have on the left a number of filters for each report and for each dashboard, and you update your filters, and the data is updated in your dashboard. This is the first was a dashboard regarding feedings. Now here it is a dashboard regarding environmental parameters. Again, you choose a data range, a date range to look at the parameters. In here, for example, you're looking on the top there at ammonia in all your tanks. You can see a peak of ammonia in one of the tanks on that specific date. And now I'm just clicking on the surface temperature. So I'm filtering only for surface for water temperature data. And I can see here the temperature profile on all your tanks and all your water sources if you have different water sources. Okay. This is now a more specific report. Okay, this is still on fecundity, on the egg collection and the amount of eggs collected per tank, and daily. This is total fecundity, and we'll see a report about daily fecundity and daily relative fecundity. Okay, so again, I'm using the filters on the left to select which tanks I want to report. Okay. So it is this report shows eggs collected and the fertilization success over time for this is for tank G1. You can change the time periods, and you can also zoom in, or in fact here, because you're looking at all the tanks, but you could also just select one tank separately. Okay. Now the fecundity and fertilization success, these are more specific requirements here. I wanted just to jump ahead a bit to samplings. Okay, the important thing here is that again, you can report on your samplings, but remember, because you have the possibility of having different sampling types, all the new sampling types can be brought into this platform. Okay, we will help you for new sampling types on creating views that allow you to report on those. Okay, And for example, oocyte diameter is a custom sampling type, and we can report that here in this application as well. So you can export this information, okay, because it's a graphical thing. We can export this as a PDF, but you can also open this report. There's a little icon there on the top right that allows you to open the report on its own page, okay? And then you are able to view the report, again, set up filters again, and here, because there is a table, you want to export this as an Excel file, and you can, and with this, so let's have a look. First the PDF that you exported of the dashboard is here, and now let's have a look at the Excel. And this is an Excel file, and you can use this to do any other type of analysis that you require. Okay. And this ends the second part of this presentation. Okay, so I don't know if there is anyone that would like to comment or question anything regarding the actual software as you saw it today.
Well, not yet.
Yes. Okay.
I think you're explaining it very well. I don't know. I have just a question: how the data is introduced by workers using a app, a mobile device, or
yes, to the mobile app. The mobile app is I guess the most common way of recording the data. So, and as I show you here, you can use the mobile app to collect practically all types of data, from sampling data, water parameters, feeding data. We didn't show that, but you can record feeding data, mortalities, everything. So again, in the mobile app, if you are recording a mortality and it's a mortality from a tank that has tagged fish, you'll be able to check the tags that are in the tank. And having read the tag of the dead fish, you can collect that this is the fish that died. So you can do that with the mobile app.
And yeah. it records the person that introduced the data and the date.
Yes. So when the person logs into the mobile app with a PIN code, so it's very easy to log in. The app knows who is the user that is recording the data, and any piece of data recorded through the mobile app as a timestamp on it, so you know at what time the data was recorded. And this this is not common to have, but I think in terms of auditability of research projects, for example, it's very important that you know who records what. Okay. Also, you know, I used to work in academia, or during my studies, my PhDs, postdocs, etc. And I know that often the slave work in these facilities is done by students that have to go on the weekend and feed the fish and do some samplings. And it is not bad that the data that is being recorded at these times is also can be audited. You know that it was Diogo or Bernardo that was there recording that data. Okay, so I think it's an important feature, but not a very common, because there has not been many applications for this purpose until today.
Okay, there are one question in the chat, which is short. It is Arif Anwari asking if there is a software documentation or manual available online, in case that they would like to get more information.
We have a we call it like a wiki. We have a wiki that can be accessed through the software. So in each page of the software of the web dashboard, there is a link to a help file. Okay, so and we are just kind of upgrading that as well as we make our transition to the Real Fish Pro platform. Okay, today users will not be logged in as I showed you, but soon they will. Okay.
Okay. Well, you have Okay, now in the questions and answers, you have a question from Gonzalo Murta asking that you have a pit that stopped working and that pit is replaced by another one if the fish information moves to the new pit.
Yes, look, we have not added this capacity here, but it's very easy to add that. Okay, it's just that it's very rare for pit tags to stop working. You know, I was running a genetic selection program years ago at Salonda Aquaculture, and we had maybe 6,000 or 7,000 fish tagged with pit tags, and we were sampling them regularly, and we were collecting a lot of data from them, and we never had one pit tag fail. So perhaps because of that, we never considered that. I don't know if at HCMR they have had such problems, but we could easily. So the data is never lost, first of all, okay. And then if we just add a new pit tag, we can make the possibility to link the data from the two pit tags and associate them to the same individual. So that's not an issue. It was never something that occurred to us, but it's a good question, and it's easy to add this picture. Yeah.
Okay. I don't know, under your experience, what type of data introduction is more difficult to introduce, or it requires more attention? Maybe the fecundity, or maybe.
Look, I guess that the recording data on fecundity, for example, measuring okay, eggs collected and then eggs fertilized, there is always some error doing that, and requires you to have in place some way of measuring that. Okay, I was working for a hatchery for many years, and we had developed our own systems about floatability of eggs, etc., and trying to measure the quality of eggs, so it is not necessarily difficult. You need to have the process in place. We are now working with CAT, which is the Center for Aquaculture Technologies, which with their department that runs genetic selection programs, and we are now allowing this Broodstock feature to record all types of genomics data, and these are sometimes large chunks of data, many fractions of a megabyte of megabase each sampling. So we are now allowing the software to capture all these types of data, okay, pedigree data, etc. So this will be complicated from a technical point of view, and that it's not easy data to collect as well. But yeah, I don't think that nothing is necessarily difficult as long as you have the process in place to do it.
Okay. Well, one final question from my side. I don't know, you have a feel for observations of things that you can observe, but it's not under a special category. I don't know, something that happened one day. I don't know. There was a storm, or I don't know.
Yeah. Yes, the software has, the software already has the possibility for you to create a diary. Okay, so you can create a diary that is linked to the farm or to the facility, or like, for example, stormy day, we could not go sample, for example, or could not feed the fish today, there was a storm. Or you can also have a diary entry linked to the actual individual tanks or cages. So we already have that. You can also create sampling types. Okay, for example, if you have some samplings that are more descriptive, okay, of course they are not so easy to analyze, but you can also create sampling types which are strings, so you can actually have a description typed and associated to individual fish. Okay, so you can do that. I see Manuel Loro here with a question
Okay.
about effectively about reusing pit tags. the PID tags have to be unique. In the system requires PID tag codes to be unique in live fish. So if a fish dies and the PID tag is reused, then the system assumes that the PID tag now is in a new fish. Okay, so this had been contemplated because this is relatively common. So even in our broodstock management at Salonda, when we decommission a broodstock tank, we remove the tags and we reuse them in other fish. Yeah.
Mm-hmm. Okay, good.
So shall I continue and do the third part?
Yes, please. Okay.
Most people are still on, so it's a good sign as surviving. Okay, so I just want to talk about examples of applications of this software platform. Okay, one of them, one example is a research institution, public or private. Okay, and the other one is a genetic selection program. The differences between them are here. Sorry, let me go back. So research institutions are facilities that have are usually large facilities with a lot of tanks, a lot of small tanks, okay, and many hundreds or even thousands of tagged fish, okay. It is characteristic of these types of facilities that there are a lot of mostly short-term experiments going on, and they can be experiments in physiology, in nutrition, in reproduction, in various areas of the biology of fish or shrimp. There is usually a high turnover of staff, not because they are fired, but because the research projects last 2 or 3 years, and the researchers come in and then they leave. This is an issue that is, in my view, relevant because it means that someone comes in, makes an experiment, gets results, makes the publication, and then moves on to another project, another laboratory. And often all the data of this experiment is stored in 10, 15, 20 Excel files, okay, or spreadsheet files, and it lives, it comes and goes with the researcher, okay. And the institution is left with very little, okay. This is, in my view, one reason why a lot of research data is lost in the system, because the institutions don't have ways to keep the data and to reuse the data if necessary, okay. There is usually high intensity of data collection. There is a lot of samplings going on, a lot of information being collected about their experiments. Mostly are non-standard data types because each experiment is on a different subject, you know, and they are measuring different parameters and different treatments. So data types are non-standard, okay? And there is usually the type of analysis that you do in these types of institutions are complex, a lot of statistical analysis, and it's always done on a case-by-case, experiment-by-experiment, okay? When you're running genetic selection programs, the story is quite different. Here we are talking about, again, large facilities with many thousands, often tens of thousands of individually tagged fish, okay? There are very standard and specific husbandry protocols that are applied day by day. They are long-term projects. Here we're talking about projects that last often more than a decade, okay? So it's important to keep some standardization over time, okay? We're talking here like very high volumes of data because you are sampling many thousands of fish regularly, and sometimes some of the data that you are sampling, for example, genomics data, they are big chunks of data. So there is high data volumes. And the day-to-day procedures depend on the continuous data analysis, for example, to cull fish, to select fish, to move fish, you know, it all depends on the performance of individuals, okay? So as an example of a research institution, I'm going to give the example of the HCMR, okay, the fish biology, the fish reproduction biology group of Dinos Mylonas, here represented by four members. The fish in that facility, they are all tagged. They have hundreds, if not thousands, of fish tagged of different species. And for them, an important characteristic of the software and a useful thing for their day-to-day operations was being able to find the fish find where specific fish are. So that easy search feature with those filters are very important for them. The stock status report, which is the image of the facility tank by tank, is also a very informative picture of what's going on in the facility. So immediately you can see what fish, what species, what group of fish there are in each tank, how many fish, what's the weight of the males and the females, and if they are actively spawning, what has been their history of spawning of the last few days. Also information like the photo period shift is important. So you have some tanks that are on natural photo period, sometimes they have a delayed photo period. Also, there is more information here. For example, what type of the color here is what source of water is being used in this tank. So there is a lot of information in here, which is useful for you to understand how your facility is today. Okay. This will now be a repetition, but in a facility like, especially a laboratory that works on fish reproduction, they are recording egg collections every day, and this is you saw how it's done, okay, through the web dashboard, but also through the mobile app, okay, and also every time they are sampling their fish, now they can use the mobile app to sample these 3 key traits like weight, length, and sex. Again, it's important for them to know that where the fish are, and so every time that you move fish around, it's important that you are able to know which tags are being moved, okay, from where to where, so that they can always trace the history of the fish, okay. Now, when it comes to common parameters like feeding, like water parameters, etc., the system also allows them to record daily feedings in each tank. If you use in this example, you are using more than one water source, and it's important you can actually record the flow of each water source, and then you can separately record the characteristics of each water source in terms of temperature, salinity, oxygen levels, etc. And these parameters can be recorded by hand and input directly on the mobile app or on the web dashboard. But also, if you are using sensors that are connected to the internet somehow, to a server on the internet, then we can also capture that data in almost real time directly into the Farm 360 software. So you remove the need to collect this data, okay? But you can have, and here you can have a very high density every minute, every 5 minutes, sampling data directly into the software, okay? A couple of examples of sampling types that research facilities may want to create, okay? I'm not an expert here, so forgive me if something does not look nice here, but a sampling type could be called hormone treatment, and it could have 2 values for example, LHRH or HCH. These will be decimal values. For example, how many milligrams are we injecting this fish of LHRH or of HCH? And you could then record these treatments on specific individuals in your tank, and then track for example, the maturity and the outside maturation stages of this treated fish, and then associate the treatment to the result, okay? If you are doing a pathology trial and you are testing phage therapy and you are injecting phage 6H on some fish, you can just make a Boolean treatment sampling type that tells you if you injected or not injected this phage into specific fish, and then see, for example, if the fish are more resistant to exposure to this or that pathogen. Another important thing in terms of organizing that and in terms of organizing information into trials is that you have your facility. Aquanetix Farm 360 allows you to pool a number of tanks into a site, okay? They become like a research project or an experiment, okay? And then you can move the fish into these tanks. You can then make treatments, record data on environment, on feeding, on water parameters, and sampling the fish throughout the system. Get your final data, make your analysis and your reports, publish your papers, and then inactivate the site. Okay, the site is inactivated, but the data is not lost. If a few years later someone makes a new trial with these similar or slightly different, for example, hormones, and wants to compare this data with the trial that was done, a few years ago at the same facility, the data will be there, and the data can be pulled back and used and analyzed together with the new trial. Okay. So this is just the analysis part and reporting. Now, when it comes to a genetic breeding, here we are talking, as I said, thousands and tens of thousands of pit tags, okay? A number of standard procedures of sampling the fish throughout their stay in the program, throughout their life, okay? Sometimes you may have complex measures like the shape of fish. This is a measurement of shape that is made up of 5 different lengths, for example, okay? And so you need to be able to encode this type of data and to record this sampling of this type of data, okay? It is very important. So typically you start with broodstock tanks, okay? You get eggs into larval tanks, and then you move them to nursery tanks. Then at some point, the fish are big enough for you to put a tag on them, and you start tracing individual fish, okay? It is important that the software allows you to do this tracing and to know always where each individual came from in their history, okay? Types of sampling types that you may need to record in a genetic selection program is, for example, these are a couple of microsatellites for sea bass. Microsatellites have 2 values. They are usually the long and the short allele, and they are measured by an integer number. So this could be a way of encoding that type of data. Condition factor is a decimal value, so you could create a condition factor sampling and measure and record that. And that complex shape that I showed you earlier, which is made up of 5 different lengths, can be encoded like this. And it means that you can then measure these 5 lengths in many hundreds or thousands of fish and record this sampling type in your and basically, that's the genetic selection is just a repetition of this process of sampling the fish, analyzing performance, and deciding for selection. So the take-home message of all this, okay, of all this presentation, is that Innovasea's broodstock management software allows hatchery managers and fish research scientists to track information linked to individually tagged fish. Okay, data can be easily collected in the web dashboard and in a mobile app, and the data can be analyzed either in the business intelligence platform or exported for analysis in more specific software applications like statistical packages. Okay. Data remains in the organization and can be recalled anytime when necessary. So data is not belonging to the hatchery manager or the researcher. It actually belongs to the organization where the trials happen. Okay, and in my view, this is a very important part of the knowledge of institutions is exactly this. Okay, and it should be kept in institutions. Okay. That's it for me. Okay, I wanted to thank again the NewTechAqua project for funding this software development. Okay, a very special thanks to Dinos and the team, Yanis, Irini, Stefano, for the hard job of being alpha testers and beta testers, and the incredibly good suggestions that they gave us to improve the software, and of course to our software development team. And especially here, the team was mainly made up of one person, Yorgos Daniil. He did an excellent job throughout these years. Okay, so more questions from everyone. Thank you very much for your time.
Okay, thank you very much, Diogo. Well, I don't know if there are more questions. I don't see them. Yeah.
I answered one further than the one that Diogo answered in the Q&A. Somebody asked about the possibility of renaming fish if rather using the tag twice, and how this can be dealt. And my suggestion is don't do that. It's better to throw away a pig tag than risking messing up the data collection and having two fish that have the same tag. It's not that expensive. I mean, you're not losing hundreds of tags every year. You probably have 1, 2, 3, 4 fish die. Keep them somewhere else. Maybe you will run an experiment at some point of time, or give it to another facility as a gift and get theirs. But I certainly don't suggest or would not consider a good idea of using the same tag for different fish.
Okay.
However, if you do, the software treats the depending on the date that you are looking at. If the previous user of that tag is died, then it treats it as a completely different fish. So it will not be a confusion for the software. But as you said, they are cheap.
Okay, but I don't know if I mean the people is still attendees are still on. I don't know,
Yes.
Dinos, maybe you can say something about your experience.
No, I think that it's something that is very, very useful. Of course, like every new thing and like every software, it takes some initial investment to learn and to be able to use. But once you do it, then obviously it becomes quite easy, and people who are using it, they're using it every day. You will enter information every day with the egg production, or with treatments, or with moving, handling fish. Some of the data that is really not something that you need to be involved with, like Diogo said, can be electronically transferred. We now set up a new recirculating aquaculture system that has its own monitoring sensors for different things: pH, oxygen, volume, water movement, and so on. All this can be inputted into the system, so you won't have to deal with it. But the information that you do enter is information that you take and you collect yourself, like the egg collection. It's not that automatically. Somebody picks them up, collects them, measures them. So this is something that is going to be entered by hand, or when you do biopsies and you take photos. All these things will be done by yourself, and because you'll be doing this quite often, then you will learn the software, and it's quite nice to have this. I'm not involved with the data collection myself, but every day at the end of the day, I get a message from the software. I get an email with all the egg production and all the information of the day, the temperature, the water flow, and things like that. So it's really nice to be able to follow it. So I would certainly recommend anybody who's running a facility to spend time to consider this. To consider the software and to spend time learning it, because after that it's going to be very easy. We used to be doing it with Excel sheets that you have to prepare and empty and enter every day, and then have to go from Excel sheet to Excel sheet. in order to see all the different data. Here you have all the data all in one platform. It becomes quite functional.
Yes, I agree that there is always an inertia to start with these things, because, as you say, you require some investment in time and effort from your people. But at the same time, we believe that we did the interface is simple enough and the mobile app is easy enough to use, that this effort is not that, this barrier is not that high, so that relatively quickly you can start using the software without problems. And then note that it can be then connected to the eggs at HCMR. They're not stocking the eggs, but they could be stocked and they could be traced through a hatchery, nursery, and grow out. So you could have a complete link if you were talking in a more production sense. You could have a full chain, let's say.
Mm-hmm. One question. I see that all data is storage in the cloud, belongs to the organization, but are you helping with the backup of the data that is entered by the users?
Yes, it's a good question. Of course, we're very careful about making sure that no data is lost. So data is backed up every 6 hours. So Today the data is in a cloud, is in a server farm in Germany, a company called Hetzner. Okay, we are over the next 12 to 18 months moving the application to Amazon Web Services, where the other applications of Innovasea are. So we'll have even extra robustness, although we are very happy with the performance that we have had in the last like almost 10 years at Hetzner. And of course, we are also very careful about keeping your data private. Data is, we use the SSL, TSL encrypting technologies, so that all the information coming in and out of the server is encrypted. We have some other systems to ensure that the web browsers that you are using cannot be hacked. So we have some coding systems as well there. So we are very careful about both keeping your data private and also keeping it safe. Okay, so yeah.
Mm-hmm. There is a question by Manuel Loro asking you if you can register for the first time a fees in the Broodstock from the mobile app or only from the desktop app?
We never, I'm not 100% sure, but I don't think we have yet implemented the tagging from the mobile app, although that would not have been difficult to implement. But I'll check, Manuel, and I'll get back to you on that, because I am not 100% sure that we cannot.
Mm-hmm. I don't know.
Anyway, if anyone ever wants to discuss this in a one-to-one, feel free to contact me. One of the purposes of NewTechAqua and of all these European projects is that we develop research, but also products and services that are useful for the industry at large. So we would be very happy and even interested in promoting the use of Farm 360 at your own operations. So feel free to contact me directly and get a one-on-one discussion.
Mm-hmm. Good.
Okay.
Okay. So, well, I see that the people stays here online. They show that they have interest, although maybe don't have more questions.
It would be, I think, useful to get some idea about the cost of the software, Diogo, and the service.
Yes, the costs it depends on the size of the facility, okay, and also because we are now starting to approach genetic selection programs. Some of them are very big, and it will have to be priced according to the dimension of the project. But we are pointing at it's a subscription software. It's an annual subscription, which I think we are pricing it at around 5,000 euro per year. Okay, but of course it will depend a little bit on the operation. So you have to see this on a case by case. Okay.
Mm-hmm.
But they have a kind of an overall idea. It will be about 5,000 euros per year, and you'll see that not all the value is not only in the way that your data is organized, but it's also in the time savings that you will have in terms of inputting data and in terms of reporting. I did not talk much about the reporting platform, but it allows you things like automatic broadcasting of reports. So you can have a report that you have, for example, for the monthly data for a trial, for example, and you can have the software instruct the software to send this report to you every first of the month relative to the previous month. Okay, and every first of the month the software will just prepare the report and email it to you as an Excel or as a PDF or any other format. So you can imagine, and you can distribute, for example, in projects like these EU projects where you have a number of partners involved. You can have the software just email to all these partners at specific times of the year or the week or month. Send the reports to all the partners, so everybody is informed. This costs you exactly zero in terms of your own time. You know, rather than having to go and make the report and then format it and then prepare it, print it, or PDF it or in the email, it is all automatically done. So number you can do.
Okay, one final question. What future developments for this platform are you working on or thinking on?
Okay, well, we as I mentioned, the software was very much developed up until now, thinking about the needs of a research laboratory like HCMR. Okay, we did add some versatility so that it can be applied for nutrition trials or pathology trials or other types of physiology trials. We are now, as I said, working with CAT, with the Center for Agricultural Technologies, and especially their genetic selection division, and we are making sure that all data that the top genetic selection program requires can be stored and analyzed in this application. So the next 2 months, our project is to develop that part. Okay, so that CAT's genetic selection programs can start using this as their data management platform, and eventually other companies running genetic selection programs can use the software as well.
Good, thank you very much.
These are the next kind of lines of development.
Yeah. Good. Well, Dinos, I think that maybe we can conclude the seminar here, no? Well, Diogo, thank you very much for being with us today and sharing your work with us, with NewTechAqua, with the webinar series. As we have said at the beginning, this webinar has been recorded and will be uploaded at the YouTube channel of NewTechAqua. This has been the third webinar of work research implemented by NewTechAqua project on reproduction. Besides the webinars, at the webpage, we are uploading publications and reports, so that everybody can access. Well, we can close you here. So thank you very much, Diogo. Dinos, thank you very much. I don't know if you would like to say goodbye or say something before we stop recording.
Just goodbye, and just follow you can have a look at the other webinars. I think they're all very, very useful if you haven't had a chance to do that. The project is finishing up the end of the year, but obviously we want to continue our research on studying the reproductive biology of all the species that are of relevance to the aquaculture, and to bring solutions that are useful and they are easy to apply in the industry, so that we can ensure that this very significant activity of aquaculture will be sustainable and will be cost effective and will be successful in the years to come.
Okay, thank you very much. So we stop here. So I say goodbye, and then I will be stopping the webinar. Okay, so cheers. Bye bye. Bye bye. Let's see. Stop recording.